Now we know that C has all the roots that we could ever want for any polynomial in this setup that we're doing. But knowing that they exist there and being able to find them are different things. So let me just say a general polynomial equation is an equation of the form. So what's an equation? Well, it's something with an equal sign. And what's a polynomial equation? Well, it's something with an equal sign where there's a polynomial on. They're just made up of polynomials. So it looks like some expression like this, where the left-hand side's a polynomial over C, A0, A1, all the way up to AN, are complex numbers. And without loss of generality, we're going to assume the leading coefficient's non-zero. Otherwise, it's sort of silly to write it. And we say that this polynomial equation, it has degree n. So there's, of course, language that we have for when the degree is small. So when n equals 1, these are called linear equations. And they look like, we don't need a subscript for these small degrees. They look like this, where a is not 0, of course. And since a is not 0, this has a very easy solution. So a formula for the roots, well, the single root, is of course subtract b divided by a. So we have a very explicit formula here telling us what the roots are for that equation. When n equals 2, we have what are called quadratic equations. And they look like at squared plus bt plus c is 0. And something that you can always do with these equations is you can make them what's called monic. So the leading coefficient is not 0, so you can divide by it. So we take that guy, divide everything by a. We get t squared plus b over at plus c over a is 0. And the roots of this equation are the same as the roots of the previous equation, the zeros rather. I don't want to deal with fractions, so I'm just going to label b over a as a and c over a as b. Okay, so this is, being able to solve something like this is equivalent to being able to solve, an equation that looks like this. So I've reset the coefficients a and b. So this is a standard trick that you always do. You always divide by the leading coefficient, make your life easier. And how do you solve something like this? Well, you move the b over as a negative. And then you complete the square. Half of a is a over 2, and then squared is a over 2 squared. But you have to add that to both sides, of course. And that left-hand side factors. And the right-hand side, I'm going to write the a here first. And then you square root both sides. Whenever you square root, you always have to have a plus or minus. And then lastly, you subtract that over. Now, this may not look like the usual quadratic formula that you know and love, but if you were to sort of square the a over 2 squared, put this under a common denominator, a 2 is going to pop out, and you can bring it under the same fraction, and it will in fact be the quadratic formula you know and love. All right, when we're degree 3, let me gold that real quick. When we're degree 3, these are cubic equations. And general cubic equations, of course, they have a leading coefficient, but without loss of generality, the leading coefficient is 1. So we can always make it look like t cubed plus at squared plus bt plus c is 0. And we'll solve the cubic equation in the next video. It's a little bit long.